Hello and welcome to another episode of the Industrial Software Podcast. I have today joining me Frank Lam. Thanks for joining me, Frank.
Well, thank you for having me.
So Frank has a automation consulting firm, Automation Consulting LLC. He does teaching, he writes books, he creates content, he hosts webinars. He's basically where it's at as far as automation and PLCs and all that kind of stuff. So really happy to have you joining us.
Thanks.
I kind of want to jump right into things. I last week hopped on his webinar that he was doing and found kind of this gateway to this wealth of information that he puts out. Starting off, there's this Mastering the Machine PDF, which I read over in detail and took all these notes on because it's like this Bible for these kind of basically like integrations projects for automation. So do you want to just talk to the audience a little bit about what that is and what the intent of that is?
Yes, Mastering the Machine itself, I came out with after leaving a company called Wright Industries. And I had run a machine building company for 10 years and then went to work for a really big kind of a multinational machine builder in Nashville, here where I live. They're now owned by JR Automation, which is kind of the biggest custom machine builder in the United States. And so what I put that document out for, it's a description of machine specification, how people, the big companies specify machines and quote them and gather up all the information and do applications and things like that. And I wrote it up just for some friends that I had that really wanted to know more about it. And then as I started creating content, I had a blog out and I realized, okay, you're supposed to have this thing called an opt-in incentive, I think they call it, which is some piece of information that you exchange for people's email, right? So that became my opt-in incentive in about 2015 when I started gathering actually, emails from people and sending. I really don't send out much, in the way of email content, but recently I've had this membership or this Automation Academy that I've been trying to bring people into, and that became a nice way to get, people's names and that were interested in the topic.
Yeah, so do you want to also just kind of explain a little bit more about the Automation Academy, who it's for, and the kind of benefits that they might get from joining up?
Sure. So a lot of people have PLC programming videos, and I'm actually friends with a lot of those people, right? Sean Tierney, the Automation Blog, he's well known for that. Paul Lynn, he was one of the first guys on Udemy to do PLC programming videos. Vlad Romanov, there's another guy that Solus PLC has lots of videos, basically markets them to companies, right? And then Stephen Gates, who's myplctraining.com. So there's already a bunch of guys doing that. And I realized after I made my videos, I really don't just want to recreate what they've done. So after creating some of them and trying Udemy out and things like that, I was getting feedback from some of the people on my site, which I started about 2 years ago, that they were really more interested in the overall systems integration picture. In other words, they knew there were, you can go on YouTube and get PLC training videos, but there wasn't anybody really talking about how do I build the whole machine? Where does design come from? How do I lay out my PLC program from the beginning, right? Starting with the I/O list, and how does that work into electrical CAD and things like that. So it kind of coincided with COVID, and also a tornado decided to come through and destroy my training facility 2 weeks before COVID started. So March 3rd, 2020, suddenly I found myself, I wasn't traveling, I wasn't doing much integration, couldn't teach live classes, so I created this online presence, the Automation Academy, to promote my stuff, create videos, put documents on and things like that. That's why I started that, and then started creating videos on other things like HMI programming or just systems integration in general. And so this Automation Academy is the place where I keep all that stuff.
Right. And just a side note, on Frank's YouTube channel, there is a video with kind of before pictures of the shop that you had that was destroyed by that tornado. And I looked up, and that tornado was deadly and tragic. And so just my condolences. That looked like an incredibly difficult thing to go through. So,
Well, it had its pluses. So, for instance, where I am now, this is my replacement facility. And what I did, instead of leasing a office space, I bought an old house. And it's about 5 miles from where I live. And, it's got enough room for 4 or 5 people to train, not as big as my old place. But I'm able to work out of here, and I've picked up other work because of that. So it's worked out okay.
a lot of the content that I've seen out there from systems integrators, it's kind of like scrappier systems integrators. Like the folks from, for example, JR are not exactly pounding the pavement, sometimes putting out as much content. But I wonder sometimes how representative that content is of the industry as a whole and of your typical systems integrator. For these smaller systems integrators, they do a lot. They are entrepreneurs. They do the marketing and the sales and the actual integration work and all that stuff. Has that been your experience in the industry? Have you had to do kind of all those things?
So when I started my company, and I started with one person in my garage, literally, just like the stories, right? And that was in 1996. And I hired one person part-time, and then it grew and hired a few more people. And at the beginning, yes, I had to do everything, but we didn't have the internet yet. So I didn't have experience in the online outreach to people. You really had to knock on doors, call people, right? And do things at that time. What I'm finding now is, yes, some people, a great example is James Dean. Some people, if you post any of this on LinkedIn, they'll know who he is. He owns a company called Appalachian Automation, and I believe he started probably with 1 or 2 people, and I don't think he has more than 7 to 10 people now. But he does a lot of outreach and marketing. He's a really good speaker, so he'll post videos about entrepreneurial things or about systems integration, or he just, he's on site in Montana and he's in an RV and he's showing kind of what he's doing up there. So that engages people, right? It wants to get to know him, because the reality is, for systems integrators, you won't just land a big job, especially as a small company. Somebody's going to trust you with some small job. You're going to solve some small problem over a couple days, and then they're going to trust you with something bigger, especially these larger companies, right? It takes a while before they're going to just turn over their really expensive equipment or have you build something that they're on the hook for, $1 million or something. So it really starts small. And so there's a lot of networking, whether it's online public networking or whether it's just personal engagement, I think. But it's really changed, right, since I had to do it, because now you have the web. It's a big world out there now.
So on the Mastering the Machine document, there's a great kind of graph of like how often people do all custom in-house work with, hiring independent systems integrators versus like on the other end of the spectrum is like a fully turnkey solution from a vendor where you sign up and you pay them and they do everything. And, you're kind of just along for the ride. What's the overall breakdown on that paradigm? Is it like most of the work that goes on actually is big vendors doing everything all themselves, and it's kind of like only on the long tail are you getting the more bespoke projects? Or is it most of the projects are bespoke and it's kind of more rare or like industry dependent where a big vendor will be able to handle everything and that's going to be the best route?
I think the big vendors typically will do everything themselves. So a good example, when I would do a project for Wright Industries, I would be responsible for all the controls in. There would be mechanical people. They'd build the mechanical part. But if you needed a vibratory bowl, it was our responsibility to go and buy the vibratory bowl, spec it out, go up and run it off, right? If you have packaging equipment at the tail end of your processing, same thing. You would purchase it, you would go up to wherever their location was, run it off, and then you would integrate it. You'd tie it together with whatever the master main system was. Some companies, so an example, I'm really small, right? I'm just one guy now. I don't have any employees anymore. And I work a lot with a company in Florida. And we kind of leverage, I'll do all the controls end of it. They'll do a lot of stuff in-house. But if they need to reach out and grab something like a packaging machine or whatever, myself or the maintenance manager or somebody would run up there and run all that off. Now that costs them a lot of time, right? Because the owner of the plant's actually doing a lot of the SCADA work, right? Using Ignition, which is their main platform, and he actually does that himself. So because of that, they spend a lot more time, but they spend a lot less money. So different companies work different ways. Denso Manufacturing, good example. They're in Knoxville, Tennessee, and they have an in-house machine builder. They actually build their own equipment. Sometimes it's beyond what they can do, so they will go out and reach out to a local machine builder, but then they'll work kind of hand in hand with them because they have machine building staff that will go in, and when they run the machines off, they'll say, no, we want it this way, or no, we want to build this part ourselves. You do this part and we'll build this part. So it runs the gamut, right? Sometimes you go out and hire 6 or 7 different vendors and tie it together yourself, and sometimes you go out and hire the JRs or the ATSs, the big boys, and a lot of those big boys probably don't work a lot with other people. They really want to take responsibility for everything, and they're going to say, if you do go buy this other part from this other vendor, we are not responsible for the success of that part of it. And it's really hard when you're specifying machinery and it has to run at a certain rate, have a certain throughput and everything. It's very easy if somebody else did the other part to say, well, it doesn't run it at spec because of that other part, and we're not responsible for the interfacing with that other part, right? So that's a lot of times why the big systems, they're quoted a certain way, and then they have to meet in the SATs and the FATs, right? They have to meet those requirements, whatever was quoted.
Hey, just cutting in real quick to say, if you're watching this on YouTube, please do hit that like and that subscribe button. It really helps out the show a lot. And if you're on a podcast player, just subscribe with your podcast player of choice, and even leave a review if you really, really like the show. Those kinds of things actually do go a really long way to support the show. Finally, industrialsoftwarepodcast.com. There's a free newsletter sign up that I never spam, and links to your social network of choice where you can follow along and keep seeing great content like this. Thanks. Let's get back to the show. So smaller integrators need smaller projects to get going, right? To kind of grease the wheels, develop your relationships, build trust, and things like that. How often is that like you're doing service work on existing things, maybe like a fix or something like that because you're local and you're around, versus like landing a smaller greenfield new project? I would kind of assume that you start off doing service work and transition over, but that I'm wondering if that's a misconception of mine and those are just two different fields.
No, they can be the same field, right? People do all kinds of different things. One of the things that happens is if all you're going to do is program and you're not going to build anything like control panels, you can easily remain as an individual person because all you need is your laptop and your software. And then you show up at the plant and you hook up and you write the program or you debug the program. You may it may be greenfield, but then they get the panel built by somebody else. They have electricians wire it in from somebody else, and then they hire an integrator for their expertise in programming whatever it is, right? But what happens very quickly is those smaller integrators, all of a sudden, somebody comes to them and says, hey, by the way, we don't have anybody to build this panel, and we don't have anybody to draw the electrical design for the panel. Can you do all that? Well, pretty quickly, right? If you're doing all that yourself, what happens in the bigger companies is while the program is being written, or while the electrical drawings are being done and the panels being built, the guy's programming, right? They're happening parallel. Well, if you're one person, you really can't do it parallel. So all of a sudden you have to either hire somebody to build your control panels or go out and find another small integrator or just a panel shop, right? A local panel shop, and have them build the controls. But once again, if you don't draw it, right, do the electrical CAD drawings, they don't know what to build. So now maybe you have to go find somebody that does the drawings or do them yourself.
That kind of veers us into this like very complicated, overwhelming world of the project management of this, navigating the multiple parties. So like first off, once again, calling out the Mastering the Machine document because that's like my Bible now to understand all this stuff. You have I think it was called a PMM. I forget what the acronym is. PMP, the Project management professional.
Yes.
Now, here's what's interesting is when you look at one of these projects, you have multiple parties. You have the manufacturer, you have the probably systems integrator, and then you have probably the vendor, right? I would kind of think that from each of their vantage points, from their first person perspective, it's their own project. So each one of those three has their own PMP.
Depends on how
Does
big
that happen?
It depends on how big the project is. So here's another thing that's a reality for the larger companies. One of the companies, and I'll let it remain unnamed, but I do a lot of work for them right now. When they were smaller, they would run projects, and the individual project engineer would run the project. They would do everything, right? They would make sure they didn't necessarily
The project engineer from
this company,
from which party?
from the integrator, which this company also builds control panels, right? Okay. So they built control panels. If they needed a machine built, they had a partner that they could go to and say, we need a machine that does this, and they would work with other people that would draw the machine out, and they could even produce whole machines that way, even though they are not a machine builder. Well, back in the day, right, they would have all their project engineers run the project, the financials, everything themselves. They'd make sure the parts got ordered. I mean, they had different people that would order the parts, within their organization, but they managed the project, and the timing of it, the project engineer would be the project manager. What's happened is, as that company got bigger, every project now must have a project manager. When they kick off the project, it will be assigned a PMP, right? A professional project manager. The problem with that is it adds overhead to the projects. So many of the projects that they used to do, that they used to be able to take on, that were, let's say, with lower margin manufacturers, right? Notorious for that would be automotive second or third tier people that, they really don't have very big margins, and they need to get projects done. So because of that, they've kind of priced themselves out of the range of those second and third tier auto manufacturers. Now, granted, they really don't want that kind of work anyway. They'd rather have the higher margin stuff that can afford a project manager, and they can do all the pieces of the projects. But that's what happens as you get bigger. Typically, I would say when you hit 50 people as an organization, you're probably going to have a project manager that's separate from the project engineer. And right there, when you quote, you probably saw references to the quote forms that you have. There are, in those Excel spreadsheets, spaces for project management hours. And when you throw, 200 project management hours on top of a project at the rate that a project manager gets paid, it kind of makes the project a lot more expensive, right? Which makes them not competitive against the 20-man shop, right? The 100 person company, now they can do things that a 20-man shop possibly can't, unless they're, for some reason, a really high-tech 20-man shop, right? But they're also going to be more expensive on a project by project basis. So they can almost no longer build the $200,000 machine. Now their minimum is maybe the $1 million machine, because they have to have a project manager on it. Yeah.
Just knowing what it's like to build things as teams. So let's picture the project where it's quoted at the beginning, and there's a timeline laid out and the requirements and everything, and the pricing ends up being exactly what the quote was. And the timing ends up aligning exactly as planned. And you hit go, and the factory acceptance test works perfectly. And I'm assuming this never happens.
Not in my experience. Now, I will say
right.
there are natural slips in projects. Things just happen, whether it's vendors not getting product to you on time. So in my previous company, the previous iteration of this company, I grew to about 15 people. And I had, I would say, 2 or 3 companies that I built machines for. One of them I built new machines for, right? That would, they were, I can say who they are. They're Howmet, which was owned by Alcoa. And they made turbine engine blade castings. And so we built a lot of the presses that would form the turbine engine things. We would build the robotic cells that would pick them out of a kind of a can and bury it in the sand, and work with those people. But my personal relationship with the manufacturing engineer there was what made that go. So for instance, if he knew when I quoted it, hey, this is probably going to take you a little longer than you think it's going to for this, and this reason, right? He would give me kind of inside information. So you need to pad your quote a little bit in either time or money, right? Because we're going to have you out here afterward where you're going to have to train the people to run the machine. Your runoff's going to be a little longer. Oh, and by the way, we sometimes process this other part that they didn't put in the quote request, right? So if you have a good relationship with the engineer there, then my timing for those projects, I was really never late on anything from the original quote because we had already put all that extra time in there. Because if I had to say, hey, by the way, I'm going on a 2-week vacation in the middle of this, my guys will still be working on it, but things are liable to be a little slower during that period of it. He would say, well, in reality, instead of, I know we said we need it in 24 weeks, we can give you 28 weeks. It's not going to kill us, right? So we change it to 28 weeks. And then another...
But that said, I would... Yeah.
Another company that I did work for.
Sorry, there's a little delay on our recording software if people are noticing some of our conversation is affected by that. So we'll try and navigate it. But go ahead.
So that was one of my big customers. Then there was another customer that mostly what we did is they would bring in raw equipment like a big press that was, pretty much... maybe it was used, and they'd strip all the controls off of it and they'd have us build all the controls around it. And then they'd use a little bit of in-house expertise to set the thing and maybe hire outside electricians to run all the conduit and the unistrut and stuff that it would take to do it. And once again, I had a very good relationship with both the plant manager and the maintenance manager. And so I knew when I go in there, okay, well, what are the other things that we need to know about this project? This isn't just a formal quote. This is also, hey, we're friends. We've done projects before together. What's the reality behind this? What's the reality that the timeline and that everything's going to show up as you've got it? You guys have to dig a big pit in the floor, and concrete people have to come in and concrete the pit. Is this realistic? And then I would also be upfront with them. I'd say, at the same time, I got this other project going on, and I'm a little stretched on manpower. So do you have somebody that you can either bring in, or can you give us a little more time to get it done? So I would say the relationship in those cases was everything. Now, what's happened with the bigger machine builders, and I had a guest on here, Doug Allward. He was one of my early webinars almost 2 years ago now, one of the first ones on my YouTube channel. He mentioned that he's an applications engineer, and he worked for Wright before they were bought by JR. And he said what's happened is a lot of the management has kind of not wanted the applications engineers or the project engineers to deal with the customer at all, right? That it's entirely done by the project manager and maybe the salesperson. But then you don't get all that, you may not get all that inside information that I was able to get working one-on-one with the direct engineer. Because it's a corporate thing where the salesperson is maybe just talking to the bean counters that have this general spec that they put out for this new line that they want to put in, right? And they're not going to give you all that inside information because there's not necessarily a personal relationship. And so the applications guy can't even call the manufacturing engineer to say, what's the reality of this? So that can become a problem for the bigger companies.
Yeah, I wondered about that because you're kind of disincentivized to be realistic at the outset until you've closed the deal. I mean, you can promise them the moon and get the project halfway going, and then you can't back out of it, and there's sunk cost already, and then the delays come in. So it probably speaks to the quality of the integrator. If they A, know enough to be able to be realistic about the projections, and B, are artful enough in orchestrating trust and the two-way street between themselves and the client that, I'm going to do this fast, but it can only be done right so fast.
That's right.
And like, I think maybe even super small integrators might worry about losing deals because of that. Like, you kind of have to navigate that risk reward of, well, I'll get a good reputation for good estimates, but I might lose the deal because someone else is going to promise them the moon.
That's possible, but I think what happens is it's hard to get into a new place when you don't know anybody, right? You got to get them to trust you on the first small job. But then when you get to the second small job and the fifth small job and the bigger job and the whatever, eventually they get to trust you so much that that's a benefit, because it's also harder for the other people to get in, right? So they're not going to come in, even if their price is maybe a little lower and they promise the moon. A lot of times, manufacturing engineers have a lot at risk when they make a deal with whoever their vendor is going to be, because if it doesn't come out right, somebody internally in that company is going to jump on them and say, hey, you spent $3 million on this line and it doesn't work right. It's constant trouble and people are having to come back and fix it. So they're going to tend to go with people that they know, or they're going to go with big companies that already have a great reputation. I think the really big machine builders, everybody knows who they are. I don't think that's a surprise to anybody. So once again, they may take a chance based on reputation for the really big ones. But then there's a lot of those medium kind of company. Well, medium, my company, like I said, was about 15 people, and that was very small for a machine builder, right? It was probably a decent size for an integrator, but it was very small for an machine builder. But when you get to that 100-person company that, has niche products and only does certain kinds of things, they may not be well known in, say, California if they're located here in Tennessee, right? Nobody's ever heard of them before, so it's going to be harder for them to get into, say, a California plant and show what they do, unless, again, people come out and maybe visit their facility, say, this is how we do stuff. Here's our panel shop, take you on a tour of the facilities. Here's our engineers. This is how we accomplish things. By the way, here's our project managers, right? And schmooze them a little bit. Yeah.
Let's say, though, that things don't go perfect and there is a change, because especially in this world, there are externalities that are beyond anyone's control, supply chain in particular. So let's say, like you're towards the end of the process and you got the wrong size screws on something or something like that. Like, from what I can tell, it seems like a lot of the documentation on this, the Gantt charts, even the models, the everything lives as files on people's individual computers. So if one person makes a change in the Gantt chart, that only exists in their world. How does a change that affects multiple parties like that at a crucial juncture get communicated to all relevant parties?
Well, if again, that's where project managers kind of come in. It's their job to share that information as needed. Some delays, right, the customer won't be told about the delay until they figure out how long is the delay, what is the impact of this? Are we going to eat this, right? This doesn't work right. We're going to go back to the drawing board. Are we going to eat this, or are we going to go back to the customer and use this argument to say, your product wasn't exactly what it was supposed to be. We have these new things. So that's where change orders come in, right? Engineering change orders. And it's all negotiation. You're right. Rarely does a project go off entirely as it's planned. Time-wise, money-wise, there's always some kind of a surprise. In one case, I remember we built a machine that processed parts, and the customer gave us a whole bunch of boxes of parts, and we ran all those parts through the machine, and they, at the beginning, they're brand new parts, and we're running them through the machine and kind of tuning the machine around them. But as the parts get run through the machine over and over and over again, before we know it, we've kind of tuned the machine around used parts, which is not realistic, right? The tool, the part itself changed, so we're making little modifications to the tooling to conform to be able to run used parts. Well, then all of a sudden we're not going to get a bunch of new parts, right? So we bring it out to the customer site and we start running brand new parts on it, and it doesn't run very well, right? Because it's been modified to run all these new parts. So we spent a lot of time and a little bit of money even retooling some things to make sure on site that it's going to run all the new parts properly. So that's one of those cases, right? Another thing that happens, especially in automotive, when you're building a brand new machine for a brand new part, that part is probably not finalized. It's like a prototype, right? So as you're building the machine, you have these parts, and all of a sudden they come down and they say, you know, we added a little curve to the back end of this little widget here, and maybe you can handle it, maybe you can't. You know, if you're feeding parts and they changed bolts, for instance, you mentioned bolts. Maybe they went from standard to metric. Well, we have a bowl feeder that was tuned around building using this specific bolt. And you put the new bolts in there and it doesn't run them. Well, what do? Do you order a whole new bowl feeder, or do you modify the one you've got? You know, that's really a change order, right? But it's notorious in automotive because the product does change. You just have to deal with it, right? It's all negotiation, and that's why things really have to be documented up front. They have to be quoted very accurately, and you have to kind of anticipate the possible things that could happen.
In describing my understanding of the current state of affairs, it's that it is individual files on everyone's individual computer. Now, that's not the case in planning for every industry. A lot of industries do project management in the cloud. And in all of my research around project management of systems integration tools, I couldn't find that many examples of that being the situation. So, you know, there's, you know, a design in the cloud that is updated live, and it's the single source of truth, and all relevant parties can go look at that and see the change history over time, but also see like the most updated current state of the design.
Well, I'll put the server in that category. Are there tools like that? It doesn't need to be in the cloud. It can be on your server. It could be on your company server, right? And because the only people who are...
But then you'd have to VPN into it, but...
No, because the people who are dealing with that product are members of that company. The customer does not have access to the drawings, the design drawings yet, right? Until it gets delivered, they don't have access to that. Now, I will say the company that I do a lot of work with here, the engineering company, they do a lot of things in the cloud, right? And they do share information with the customer because their main customer is probably well over 50% of their work. So there's a lot of incentive to share documents in the cloud, right? So they have that. And they're used to doing, for instance, they even have an OEE product that is meant to monitor the machinery in the cloud. It is web-based, right? It's tied into the machines, and people can add sensors or whatever to this thing called the OEE optimizer, you know, from either side. They don't have to come to the vendor to add the things that they want to monitor. They can add them themselves. Either side can, you know, as long as they have a login to the cloud-based stuff, either side can do that. So in that case, that's like shared software, right? But drawings, no, design documents are rarely shared with the customer before delivery, and then it's theirs also, and they can have their final copies, right?
How about like the Gantt charts, like the project management side of that? Is that ever found in the cloud, or is that?
Probably not, because it's such a small document, and there would be a update. There'd just be a schedule. Hey, every week we're going to update the Gantt chart. Because it's not really a living document, right? The Gantt chart, once you have all the plans and everything, the project managers often are managing multiple projects. So they're not working on the Gantt chart all the time, right? They bring it up and they modify it as needed. If somebody comes back and says, hey, we can't get, that's the big thing now, supply chain. Hey, we can't get parts for whatever. Well, once a week is probably sufficient update for a project that's a 4 to 5 month or 6 month or more project, right? Once a week is probably sufficient. Now, if there was a surprise, big impact, right? The Gantt chart's supposed to go out on Friday, but Monday, all of a sudden you find out that you're not going to be getting these products. And so the project manager analyzes it, makes some phone calls and says, are you okay with substituting this other part? Right? Oh, by the way, either way, it's going to delay the project and it may add cost. So they're talking about that stuff. And then the documentation, still the update, right? They'll have like a weekly meeting or something like that. So that it's not necessary to put the design documents and the Gantt charts and things like that on the cloud. It is necessary to put them on the server because all the project people in the company are sharing, right, those documents, working off the same spreadsheets or documents or whatever, but not necessarily cloud hosting it, especially for a company that's in one building or even two locations. The customer that I work with right now, they have an office in San Diego, they have one here, and I think they have a couple remote people in Phoenix. So those people can all just log into the server. It's not really cloud-based. It's just log into the server, VPN in, and check the documents as they're needed. Yeah.
Do you know of any popular software that's used to do that on that server? Or is it just kind of like ad hoc? Each company just has their files there?
I think it's just files. I know for me personally, I use AWS. I believe this company that I do the work for, they use a different platform. But I think a lot of the big document hosters, AWS, Azure, I think there's a lot of just cloud-based hosting platforms, and a lot of those are adding. It's not so much a software thing, right? So you would open, for instance, a Microsoft project file, the Gantt charts and everything, with the local software that you have, not necessarily a hosted software. Now, in contrast to that, I actually do log into my Miami customer's server, and I can get into any of their machines directly from their server, right? And that's all, obviously VPNing, and that's all firewalled and all that kind of stuff. But I can remotely operate the software on their server. They'll have it installed there, and I use their software, not my software. So it can be certainly done. But as far as hosting it on the cloud, I mean, there's plenty of big companies, the Googles and the Amazons in the world that certainly, and Microsoft, right, that host all that stuff, including the capability to run software on the cloud to open things. But most companies, that would be expensive, right, to put, who owns that software? Or are you paying for licensed software on Microsoft's platform, right, to run the software on their place rather than running it on your own computer? You have to have the software anyway. I know a lot of people are going to subscription-based software, but I think things like AutoCAD and Project and those things, everybody's going to have a working copy of that anyway. Project managers and designers are all going to have a local copy, and then they'll work on things, and they'll probably post the end files, but they won't have multiple people working on them at one time on the cloud, say.
All right, switching gears a little bit. So when I was going through a lot of your materials and watching your webinars, once again, just to emphasize, everybody, go to the YouTube channel and just watch through some of the webinars because they are so full of little anecdotes and insights. And if the Academy is just more of that even, it's worth the price of admission times 10. So amazing webinars. So that's besides the point. But in those webinars, you spend a lot of the time actually showing what these spreadsheets are that you use. A lot of times to optimize a lot of what I understand as the PLC design. If these are kind of like a best practice to the point where you're including it in curriculum for the people that you're teaching and things like that, I find it surprising that they're not a part of the software itself. That if it's that kind of like beneficial and critical, that the software doesn't pull in those features. Is there a reason why you think that these are things that are best done outside of the software and why they don't pull them inside?
I don't think there is the software, right?
Sorry.
Yeah.
So like, I think so I come from web development, and so I kind of have to reverse engineer everything that's going on in these fields to its equivalent. But you have these pieces of software, and I think it's specific to like Rockwell or specific to Siemens, of where you're doing the ladder logic to design the PLC. In my world, that would be like an IDE or something like that, which, by the way, is all totally free except for like this one called IntelliJ. But like, once I understood that you have to pay to even do that, I was like, oh my gosh, these walled gardens are walled so high and the gatekeepers are so strong. It's kind of, that's a whole other issue. But anyways, so to be specific, those are the kinds of software that I'm talking about that I saw these spreadsheets used for. So Why do you think that they don't include that function?
So let's take Allen Bradley as a good example. They're Rockwell, right? Their software is very expensive. It's probably 70% of the U.S. market are PLCs. So it's widely used in all the plants. Most people use it. But the thing that needs to be exchanged, for instance, with a mechanical engineer, he doesn't know anything about Rockwell software. He doesn't care, right? He may have drawn just a cabinet and said, well, there's a bunch of control stuff in there, but he really doesn't care about that. Yet the names of all the things in that machine need to be shared between the people. So everything is Microsoft compliant, so what better to use than Excel, right? Because you can export things as comma delimited files from Rockwell, and you can import it into AutoCAD, right? So, or SolidWorks or whatever. So a lot of times what happens is there's an initial document where you name everything, and if everybody works off that initial document, then the names of all the things in the machine are agreed upon and standardized. But that's what I meant by there is no the software, right? There's many different pieces of software, and we have to use all of it, and we have to use something that is in common, which is generally Microsoft. Another thing people don't realize about, Allen Bradley software doesn't run on anything other than a PC. You're not going to run it on Mac. You're not going to run it on, I don't know what other, Linux. It runs on Microsoft, right? So all the other Microsoft suite works with that. All the things that you can import and export, XML files, whatever, that's all kind of native stuff. And that's kind of the base documents that a lot of times you create those documents off of. Now, I'm gonna make an exception for that. Allen Bradley has a toolbox, if you want to call it that they are heavily pushing. That is for design, right? And they want you to use their toolbox. The problem is, let's say you're not using Allen Bradley's servo drives. You're using Mitsubishi servo drives. Their toolbox doesn't include Mitsubishi parts. They don't want you to buy Mitsubishi parts, right? So all the things in their toolbox, you would have to somehow go to Mitsubishi and, for instance, import all of the DXF files for the drawings or whatever. You would still have to go outside of the Allen Bradley stuff that they're promoting and use third-party tools to get everything into your project. So most people, because of that, stick with, I think they call it Asset Manager is the Allen Bradley thing, but most people just stick with Excel. Some of the bigger integrators, I would say maybe if everything you're doing is Allen Bradley, yeah, they probably use components of the, I think, integrated architecture builder or something they call it within the Asset Manager. But, I think there is an entry-level free version, but then it costs after that. And two, it's not compatible with all the other major manufacturers, right? Siemens and Allen Bradley are like this. Siemens is the biggest in the world. Allen Bradley is the biggest in the United States. And then you've got a lot of other players, right? Probably bigger than Allen Bradley, even ABB and some of those things, right? For big drives and things like that. Allen Bradley is not going to go out of their way to accommodate ABB or Siemens products in their setup.
Now, I have to assume in history, third parties, other companies have come in with their intention and value proposition being, well, you have this fragmented landscape, so we're going to write some common thing on top of it that will then be like transpiled or whatever into something that can be understood by the others. I have to assume that people have done that, but I don't see a lot of it around. So first off, has that happened? And second, why did it fail? Or is it not failing? I've seen people trying to sell things like that.
They're not cheap. They're several $1,000s at least. And certainly that prices all the small integrators completely out of the market. They're not gonna buy something like that unless it's proven to improve their productivity or something. And so the only way it's going to get proven is for probably a sales guy to come in and persuade, the integrator that, hey, this will save you X amount of money and here we can prove it. But that's an individual sales effort. I've seen things like that advertised and promoted. But for instance, none of the big boys that I deal with use it. I'm sure those vendors that are creating software like that really want people to use it. I took a swag at trying to create that stuff myself. I tried to make a super spreadsheet that could be used with not only all the Allen Bradley stuff that I do, but I could specify, right, this is Mitsubishi, this is Siemens, this is Omron, and it would go native on whatever that product was. It was way too much development, and I'm not that kind of a programmer, right? I'm really not the Visual Studio .NET. I use it for controls, but I really don't use it for actual building applications as such. And it turned out it was going to involve a lot of big databases, and and just it was beyond what I really felt comfortable doing. So I kind of gave up on it. I have a kind of a hybridized tool that I sometimes use or I present in class, and I say, hey, if you want to take this further, right, you're welcome to take all the source stuff I have and modify it and play with it and make it work for whatever your platform happens to be. But most of the people I deal with are dealing with only, say, Allen Bradley and Siemens anyway.
Yeah, then you're not as incentivized to break out of the walls. Community amongst this community seems to be in short supply. And I can see why you want to do the Automation University and get people kind of like together, because I haven't found that many places that are like gathering, like watering holes for this community. I might just be missing them. I think a lot of them are just in person or trade shows and things like that. But one of them I did find is the PLC subreddit. And I could tell from that people don't like this status quo. I mean, I sorted by the top posts in that subreddit of all time, and they were all memes that were complaining about things adjacent to this. Like, one of them was like someone sitting down with Rockwell, and Rockwell saying like, okay, you got to pay for this and this and this and this and this and this and this. And so am I right that like people know that this isn't the dream scenario, but they just kind of deal with it because it's how it is?
I think integrators and controls people and machine builders are very busy people, usually doing their job. So you add that to the networking necessity. I've kind of been, I'm at the tail end of my career. I'm in my 60s. So for me, using LinkedIn and things like that is probably sufficient. I'm not so busy that I can't do that networking. Now, interesting you mentioned about the community. I am now making the Automation Academy community free for everybody. So what that's going to be, it has forums, it has groups, and it has profiles. And you can fill out your profile kind of like LinkedIn, right? I'm using Buddy Boss as a base. It kind of goes back to some history. I think I mentioned it in my last webinar, but when I took Buddy Boss off because I only have a few members and they weren't using it really, right? And it was kind of an unnecessary cost, so I ditched it. And then I decided later, okay, I want to put it back because there's a few more members here and like to try it out, and it broke my website. So I decided to put it on its own platform, and that came up today. The developers actually got it on the platform today, and it's very vanilla right now, so it's not open yet. But it has a open login. If you could happen to find the local login, you could sign in right now and put a profile on there, right? But and it's got forums, groups, and profiles. Now, my incentive for doing this, right? This used to be entirely behind the paywall. My incentive for doing this is anybody who joins the academy and has a business is going to be able to post a profile with their website and what their services and things like that, and I will organize it more or less by region. So, for instance, the guy I interviewed last week, he would have a lot of incentive to put blue collar automation in Memphis on that site, so that other people who are looking for that, and this takes years. Unless you have massive marketing, people aren't even going to know what this thing is. Like you said, you found the PLC subreddit. There's also some groups on LinkedIn. There's Facebook groups. There's PLC Talk. There's plcdev.com. There's a lot of resources, but I don't think a lot of people necessarily use the forum. Now, oddly enough, you go to something like Ignition, right? You might find an Ignition forum with thousands of people on it because they're all eagerly trying to learn Ignition, but it's going to be very specific to Ignition. Same thing with Beckoff. There's a new thing. What's the name of it? It was actually up here. Unofficial Beckoff support forum. It's beckoffsupport.com. They just opened it, and it allows you to put a profile, and I think it's got forums on it. But again, it's going to be specific to Beckoff. Mine is going to have groups of everything. So there'll be Alan Bradley, there'll be Beckoff. I'm hoping to get Jacob Sagatowski, the big Beckoff guy, to come in and kind of manage that thing. In exchange for him managing it on this public site, I'll give him a profile. I'll say, hey, you can put your services, and you're from Germany and this is what you're good at, and you can just put that on there, right? But the incentive will be, by making this free, that people will hopefully come to it and they'll say, hey, these other people are advertising their services on here. How can I advertise my services, right? Well, you can get in for the low price of $9.99 a month, right on the low end, and you can have a profile here, even if you don't use all the files that I've got in the Automation Academy.
So if that's ready for folks to go to, where can they go?
Well, so it's not really, it's literally today.
Okay, now coming soon. Follow Frank Lam, which you should do anyways, and you'll see.
I've got it's still under automationllc.com. So if you go to automationllc.com, you will see a splash screen for the login. It's under there right now. It's like, I'm going to take a guess, community.automationllc.com. That's a guess. That's probably what it's under. Okay. But I think.
But in any case, follow Frank anyways, because
there are two users. I know, myself and my daughter. And my daughter owns a branding company, so she's the one who has all the developers access to people and sets up all this. She did a good job, but it's very, like I said, it's very vanilla looking right now. And they said they're still importing all my forums and groups from the old site, because it was on, it was in the Academy site, and they have to pull all that off and put it on the new domain. So.
Okay, so we're coming up towards the end of our time, but I have this huge list of questions. And so I'm going to try and squeak in a few other ones if that's
Sure.
okay with you. So first off, something that I've been curious about is the HMI UIs themselves, because if I understand correctly, I think that folks like yourself build the actual user interfaces on the.
Yes.
Am I correct? So what are some good resources or hubs for information or something like that I can go to learn more about how people do that? And what popular things are.
So again, all the big manufacturers have their proprietary thing. So Allen Bradley, Rockwell, right? Okay. Their thing is Factory Talk View. ME is the HMIs themselves, and SE is the SCADA, which means just a computer, right? And then you deploy an an SE application or an ME application. The SE would go on a computer. The ME would go on their particular, panel view pluses is what they call them. Siemens has WinCC, and both names, the SCADA version and the HMI version, are both called WinCC. And then they have a whole bunch of proprietary, touchscreens and things that go with that. There are independent touchscreen manufacturers. One of the ones I recommend is WineView. One major reason is 10-inch touchscreen, $350. Color touchscreen with free software, right? Software is totally free on it. Works very well. They've got 40 or 50 of them installed down in Florida, and that's a nasty place, right? Lots of humidity, lots of lightning, and we've never burnt one of them up. So those work pretty well. Another company, and I just met the founder of this about 2 weeks ago. It's called Advanced HMI, advancedhmi.com. It is free download, and it runs on Visual Studio. So it's a WinForms type application, and he gives you some widgets, and then he also sells better widgets, right? So you can buy his cheap little, you get all the basic stuff for free, but if you want a fancier graphs or meters or some of the objects, fancier buttons, it's like $3, and you get you can use them on as many applications as you want to. Now, one of his rules is it comes with the drivers for the PLCs, but it is you have to host the source code on the computer you deploy it on, right? It's kind of a shareware type thing, or fair use. I don't know what you call it, but he kind of states that there. So if you want to use it on a on your own application that you're releasing commercially, you would have to buy his like Allen Bradley driver, which is like, I think $200. And that I believe you can deploy on multiple HMIs. That guy's name is Archie Jacobs, advancedhmi.com. So that's another really good resource. Again, that's computer based, so you would run it on a, he sells computers too. He sells little touchscreen computers, I don't know, Advantech or whoever they are, that his stuff runs on. Beckhoff's PLCs and their HMIs run on standard computers. They are going to strongly insist that they run guaranteed on their own computers. So they want you to buy the hardware from them. And of course, since you're also the IO anyway needs to be from them, right? EtherCAT is a big networking thing. You would get that stuff from them. But all the manufacturers, Automation Direct, another great resource, right? They sell PLCs and HMIs and software, and it's next day delivery from Atlanta in the United States. So a lot of people use Automation Direct, from everything from your terminal blocks to your, like I said, HMIs. Easy Automation's another one, just like Automation Direct.
I guess I'll cut my list down to like one last question, I guess. I got to thinking when I saw the video of the tornado and what happened with your lab. It must be extraordinarily worthwhile to have a physical lab. You wouldn't have gone to all that trouble if it wasn't really valuable to have that, versus something like simulation software. Like I've seen there is a lot of simulation software out there where you can basically try out anything that you want to try out virtually without the need for a lab. But it must still be valuable to have the physical things with you. And so what is that value gap? What do you gain that makes people want to have the physical?
You'll notice that in those simulations, they have moving objects and everything, but how do you teach somebody to adjust flow controls on a cylinder to change its speed and to make it move smoothly? How do you teach people how to tune servos, right? Servo drives, tuning them is an art in itself, and making the motors move correctly and stop at the right spot and move at the right speed. Tying the products physically together. How do you make one product communicate with another product, right? Communications is a huge part of this. Lots of different serial protocols, lots of different conversions. All these, Allen Bradley and Siemens and Beckhoff, they all speak different languages. So how do you make one of them talk to the other, right? And there are products that work with that, or you can use some kind of intermediary stuff and use the PLC itself as a gateway. Come in on one language and go out on another language, right? And talk to a different device. So that's a lot of what you get. Adjusting sensors, right? Setting, there's an art to even things like adjusting photo eyes. And one of the things that I did in my lab, I don't know, you can't really see a picture of it here, but I had a conveyor that was actually from an application where a mechanical guy had designed this, and it had cleats on the conveyor. And you had sensors, right, that picked up the cleat. And what happens is you hit the first sensor and it tells it to stop, and it stops at the second sensor, right? That's the idea behind it. What happens when you change the speed of the drive? You pass the first sensor, you got a stop signal, and you miss the second sensor. It doesn't stop in the right place. So that was one of the things that they learned very quickly. Hey, here's all this hardware, now make it work, right? And that involved either changing the positions of the sensors every time or having canned profiles of speeds of those sensors. The reality is all that simulation stuff, and I do simulation, I do that extensively myself. It doesn't touch on reality, right? And most of the simulation software is actually missing the major components that we use. I'm trying to think. One's by Real Games, Factory IO. Almost all that is material handling. It's conveyors, and it's shrink wrappers, and it's maybe some elevators and things like that. But they don't have things like dial tables. Dial tables are common in automotive manufacturing, where you're doing something at every station. There's just many missing components.
Do you think that this might change in the future? Do you think there might come a day where that's the de facto standard, is simulation only?
It would be hard. we're getting into the realm of something called a digital twin, right? So a digital twin is a duplicate of a machine in every way, right? It would have solid modeled elements for every sensor. It would have, you'd be able to click on that sensor and get every piece of information, 24 volt, syncing or sourcing, retroreflective or whatever. The next step would be able to say, okay, I want to adjust the margin on this one sensor and make sure that I'm getting enough light. I want to physically turn it and make it miss the reflector that's on the other side. We're a long way from that. And there's got to be some incentive for somebody to put that together. This stuff, takes a long time to program. As tools get better, right, we're getting much more modular. People will create something like that and maybe pitch it into a library, and then, hey, I can just bring that little photo eye object into my library. That'd be great. But there's so many things that have to be created to do that. And what I found is, like Factory I/O, they released it and it was just for material handling people. I think for very simple applications. They never got into real manufacturing stuff, robots and pick and places and various servo actuated pallet tracking things. That's what's in reality right now. So reality is outstripping the simulation is what's happening.
All right. Well, thank you so much for all of this information and for sharing your time. I think we've called it out a little bit, but just to redirect people really concisely, the best place to go to follow you and reach out would probably be your website.
LinkedIn is great. I'm on LinkedIn. I pretty much connect to anybody that requests a connection, as long as they're in a technical field or they're not just trying to sell me something. That's a lot of what you get is somebody trying to sell you something. But so that, or my website, automationllc.com, my blog, I post things there less frequently, but that's a free resource. Got tons of stuff there, automationprimer.com. So LinkedIn or those two are probably the best way.
Everyone should go check that out. Join the Automation Academy and keep an eye out for the forums, because that's going to be an amazing resource. Once again, thank you so much for your time, and highly encourage everybody to go check Frank Lam on all those locations.
Thanks, Kevin. And it was a pleasure talking to you.
All right. Great.
All right.
Have a good one.